Welcome to the 2019 WJEC Greenfoot question workthrough. Now, this exam paper caused a lot of concern for people as they were working on these questions, mainly because they were a slightly different format than they were expecting from years past. This was to be expected because it was a new format of exam, but still people had a bit of a freak out. And when you combine this with the fact that this was the exam paper that was accidentally completed in the more modern version of Greenfoot, meaning that some of the latter questions wouldn't actually work, this exam paper was a bit of a shock to most people. Now, it's reasonably straightforward to work through it, and in fact, I will work through it all using the 2.4.2 version of Greenfoot that the exam board say we need. The first question, question 7, did confuse a few people. It's only 5 marks, but what we're looking for here really is to create this environment. So we need to create a new scenario in Greenfoot, and it needs to be called Final Aquarium 7. So I'm going to call mine Final Aquarium 7. You'll see that we've got a Greenfoot window with nothing much going on. And the first job is to set up a new world that's called Tank. The background image is a 9x9 grid using the image water. That's in the aquarium folder here. So it's this image. So we're going to create a new world by going into world, right-clicking on it, and going to new subclass. Now we've been asked to call it Tank, so we will do that. The image we need to import from a file, and we'll bring the image in from over here from water. Double click on that, we say OK, and that creates the tank. Now we say compile before we can do anything else, and it creates a basic version, but that's not a 9x9 grid. So we need to open the editor, and once we're in the editor, we'll see that the size is actually measured in pixels. What we need to do is set the width to 9, the height to 9, and then here, this will be the size of the image. Now the image is usually about 60 pixels wide, so if we set it to 60 and compile, hopefully we should have a 9x9 grid of the right size. There we go. The size, by the way, is something that changes from year to year, so it's something to be a bit more mindful of, but they pretty much stand on that. So we've got our environment set up, we've got a tank, we've got a 9x9 grid, and we've got water. Very simple stuff. The next thing are the actors. We need to create a new class called fish and populate the world with 2 fish. So new subclass in actor, calling it fish, and do be mindful of the capitalizations. I'm going to import a picture. Lovely picture, WJC. Thank you very much for that. I'm going to bring the fish in, and I need to compile it, and then I can bring in 2 fish. Now, every time I click compile, it will reset. So you need to be mindful to save your world as you go. I then need to add another actor. And this time it's a shark, and I need to have code that allows it to turn and move at random, which is something we've done a million times in our practices. So I'm going to bring my shark in here, go for my shark. Oh, I haven't given it a name, so shark would be a good name for it. Click OK there. Now we compile it to get that to work. Again, it wanted 2 fish, and how many sharks? Let's have a look. Popular with 2 sharks, a shark there and a shark there. I'm going to save my world to stop me having any fusses as I go, and I'm going to edit the code for my shark. Now, traditionally, WJEC would have given us some code for movement. Now, because I want it to turn and rotate at random, I need to use a little bit of a trick, which is to set a random number. So I'm going to set a random number called direction. So because this is a strictly typed language, I need to start with the definition of the data type, so int. Then I need to tell it what the name of the variable is. So I'm going to call mine direction. And I'm going to set that equal to a Greenfoot function called getRandomNumber. If you've seen any of the other workthroughs from other people, you'll see that this is commonly there. Now I want a random number between 0 and 3, so I'm going to put a 4 in there. That gives me a random number up to the number 3. Then I need a series of ifs, and this is broadly similar to things we've seen before. I need to say if the direction is 1, double equal symbol there. Now the nice thing about Greenfoot is that curly braces, I'm just putting a set of curly braces there, explain what I need to do. This is what happens as a result of the if statement. So if direction, get a number between, actually let's start with 0, is it, rather than starting with 1. A number between 0 and 4. If the direction is 0, what are we going to do? Well, it's asking us specifically to rotate and move. So what we need to do is set rotation. And all we do in set rotation is we give it a number. So it's a number of degrees. So 0 degrees should be up, it should be north. And then we're going to set the location. This is exactly the same as we've seen a million times before. Now we need to get the X direction and we need to get the Y direction. This sets the location of this particular item to the X and the Y location it's currently at. And if we're moving up, what we need to do is take 1 away from the Y direction. That will move it towards the top. Let's just compile that and test it to check it works. Now, randomly, it should be moving up. Now, as you see, the rotation didn't really work, so let's have a quick look at that. I think what was likely the case was that 0 must be the current direction. So if I want to rotate it to the left, I'd need to rotate it 270 degrees, which is basically 3/4 of a turn. And there we are, they're pointed upwards now. So the rest of this is reasonably straightforward. We take this chunk and we copy it. And we're basically going to paste it 3 more times. If we take 1 as being going down, then we add 1 to the Y direction. And we need to go the opposite of this, so that would be 90 degrees would be the opposite of 270. If we take 3 as going left, we need to take 1 away from the X direction, and we'll need to set it to 180, which is the opposite of the starting point. And the final one there is if our direction is, sorry, I've put 3 there instead of 2. If our direction is 3, which should be right, then I'm going to set the rotation at 0. So that's pointing right, because our shark is currently pointing right. And I'm going to add 1 to the X axis. So what we've got here are 2 very simple commands: set the rotation and put it in the right direction, and then move it in that direction. If we compile that, that should work okay. And if we run here, again, drop the speed a little bit, but you'll see they are pointing and turning in the right directions and moving in those directions as well, with a reasonably simple amount of code. And a lot of that code we can reuse for other areas. So that's the shark done. Let's have a look at D, a crab now. So we're going to create a new actor called crab. We're going to import from a file, and we're going to bring our crab file in. If you're wondering where these images are coming from, by the way, this is the file the exam board provides you with. Now let's have a look. There should be a crab in the world, so we need to compile it to get that working. Stick a crab in, and I'm going to save my world. Now, the crab here moves left and right randomly, and this is where that code we just added to the shark comes in very handy. Because if you remembered which one was left and right, you can copy that code. I'm going to take the entire chunk a moment. I'm going to stick it in my crab. Now we always put it in the act method because the act method is what happens every frame. Now this time I only want it to go left and right, so I'm only going to give it 2 numbers. Now the bottom 2 are actually my left and right, so I'm going to delete the first 2. But all I've got to do is change these numbers. 0 and 1. That means they should only go left and right if I've picked the correct ones. Let's give that a go. And run it. There we go. Our crab is only moving left and right and is rotating in the right direction as well. Make sure you save it. So with that complete, we need to move on to the very next question. Question 8 is a written response question. So you're writing these answers inside your answer document, which is this guy here, the electronic answer document. So hopefully you've been filling this in as you go. Question 8, you'll see, has just a gap for A, B, C, D, and E there. Now, what we need to do is open WJEC ANTS 8. So let's do that. WJEC ANTS 8. And what it's saying is, from that, identify these things. Now, this is simply an idea of learning. Now, a superclass is a class that is inherited from, so it is the main name. In this case, world or actor are our superclasses. They're the type of thing that we're inheriting from. So I'm going to go for world. Okay, B is a class. Now, a class are any of the actual items: the ground, the water drop, the counter, the sugar cube, the ant. I'm going to go for an ant in my answer. Now, the difference is that a class is an instance of a superclass in most cases. They inherit all the methods, all the code from world or from actor, and get a little bit more as well. Private property. Well, let's have a look in our world, because normally we have a private property in there. Let's have a quick look. We have a private method here, but not a private property. So let's have a look through the rest of our code. There doesn't seem to be anything in ant. Aha. In counter, we've got this guy here. Now, this is a private property. A property is one particular piece of data, and this is a private integer called total count. Now, what that means is that only the counter class, this particular bit of code, can access this, which is why we need functions to manipulate it. So ours would be total count. So let's put that down as our example. D is a comment. Now, hopefully comments are straightforward for everyone. There are some comments here, but there's nothing in them. Let's see if we can find a bit of a comment on one of the files where there's something written in them. That it's not always the case. We may have to. Let's have a look on the sugar cube. Nothing in the sugar cube, unfortunately. Let's look in the ant, and hopefully there'll be something. There we go. It's just a case of looking through. There's a comment. We can copy and paste that in the ant class. And it's not massively important that you explain where it is, but if you're going for the full marks, you might as well make sure you get them. And finally, E, a method's run in each frame. That's the act method. The act method is what happens each frame. So that would be a good answer there. That question being done, we move on to question 9. And finally, the one we've been waiting for, the big question, which is more similar to the examples we've seen from the past and the past papers. Now, please do have a look at the examples WJEC have released. Some of them have 2 counters, some of them have 2 characters that are controlled with different control schemes, and there are lots of different things going on there that they could ask you. Now, to me, that seems like an obvious hint that they will be doing something a bit different as we go through this. It's not all going to be the same old that we've seen time and time again. So let's see if we can build this. It's WJEC Ants 9. I'm going to open it up. And this, in fact, was the question that caused the problem last year. This was the question where apparently a number of the parts couldn't be done in this version. Let's compile and see what we get from the start. Brilliant. Part A is always to populate the world. They want an ant. So we'll give them an ant. A water drop. We'll give them a water drop. And at least 2 sugar cubes. So a sugar cube here and a sugar cube here. I'm going to quickly save my world because you need that in order to be able to move forward from there. And that's part A done. Edit the water drop and sugar cube objects so they turn and move around the world at random. Now at this point, we've already done this once. So let's go back into our aquarium. Let's grab our sharks code. Let's copy all that code for moving it at random, and we'll stick it into our water drop and sugar cube. The beauty of this is once you've written it once, and remember this needs to go in the act method. Once you've written it once, you don't need to worry about it again. So the sugar cube and the water drop, I think, are moving around. Yes. And in fact, once you get going, a lot of this is copy and pasteable. Lovely. And now if we run it, there we go. Everything's moving and turning at random. Now, it hasn't particularly asked us to turn it, but in the old style exam papers, they used to turn them anyway, so it's worth doing. Actually, no, it does say turn and move. So it's got both of those things going. That's a nice, simple job. And of course, if you need to write it from scratch because it wasn't part of the previous question, that's reasonably straightforward as well, isn't it? Okay, part C, edit the ant object so that it moves at an appropriate speed in the direction of the arrow. Now, I'm going to go for the ant and get his code up. And I'm actually going to paste in the random movement code because it's very similar. The only difference is that we don't have direction. What we have is a reasonably straightforward way of getting the key press. Now, if we said 0 was up, then we need to go into Greenfoot, is key down. Now, don't forget, is key down is a method that just checks that you've pressed a key on the keyboard. It is not a method that looks for the key down arrow being pressed. In the brackets, you simply tell it in speech marks what key you care about. So this one was up. Now I'm going to take that stuff and I'm going to replace, I need to get rid of that comparison as well. So the only thing in the brackets is us saying, has that key been pressed? Do the same with this one. This one happened to be down. Remember the way a computer screen stores its information about direction is that the top left corner is 0, 0. So we add 1 to go down and take away 1 to go up. In the x-axis, we take away 1 to go left and we add 1 to go right. So what we should get here, if we've done it correctly, is an ant that can move. So run it and check that you can move that ant with alacrity there. Beautiful. And notice they're all moving reasonably simply with each other. Slow down the speed if you want to test it out. Occasionally, you may get a crash where some of the movement doesn't work after you've stopped it and reloaded it. Don't panic about that. As long as it works when you run it for the first time, you're okay. Save it here because we've got a decent bit in there. Okay. Edit the ant object so that it eats a sugar cube. Now, what that means is it's going to delete the sugar cube from the world, isn't it? Now, the way to remember how the collision works is you need to always put the code in the thing that doesn't disappear. So as the ant is not disappearing, we're going to put the code in here. Again, we're in the act method. We're just going underneath this movement code and we're going to work here. Now, what we need to do is tell the ant about the world because all the ant knows about at the moment is itself. So we need to tell the ant that there's an actor that's called sorry, this is a sugar cube, isn't it? Yes. There's an actor called Sugar Cube. What I'm going to do is type the name exactly as we see it here. Same capitalization. Actor Sugar Cube. And that tells the ant that there's a thing called a sugar cube that exists. I'm also going to tell the ant at this point that he lives in a world. So the world is called ground. So I'm going to do ground. And then give it a name. You could call it anything you want, but the general way WJEC like it is that you take whatever the capitalized version was here and you give it a name. So I'm going to call it lowercase ground. This gets a bit confusing to talk about, but is reasonably easy to remember. So I'm going to say the ground is the ground get world. That will tell us which world we're currently in. And so now the ant knows about sugar cubes and the ground. Now, we also need then to tell it which sugar cube we care about. So the sugar cube I care about is one that get one object at offset. Now what that means is, I think I've missed a capital A, sorry, get one object at offset. There we go. It's all camel casing in Java. Now what this line means is I need to find the sugar cube that's overlapping me. So if it's overlapping me, compared to me, it will be at 0, 0 in terms of grid reference. And then the third argument is always sugarcube.class. And the type of class it is, this is basically saying it's this type of thing. Okay, so the sugar cube I care about is the one that is on top of me and is a sugar cube. That's how that one works. Now, what we need to say then is we need to say if the sugar cube is not equal to null. So what does that mean? Well, null is the absence of something. So if I look on top of myself and say, is there a sugar cube on top of me? And the variable sugar cube contains nothing, that's because there's no sugar cube on me. So If it's not null, that means there is a sugar cube on top of me and I need to deal with that. So if it is on top of me, what we're going to do is going to take our ground and we are going to remove the object, if I can spell, remove the object of the sugar cube. Now notice this is reasonably straightforward. I'm leaving a lot of space in this subroutine here, in this if statement here, because I'm going to be adding to it later. Click compile. And I am being a mug because I've called it sugar cube with a lowercase c there. And sorry about that. So if I compile it there, I'm almost convinced my shift key is not working. I can't be this much of a mug. There we go. So we've got our sugar cubes working correctly. It's compiled correctly. Let's see if it works. When I run it, if my ant goes over the sugar cube, you'll see that the sugar cube disappears. Again, which is why it's important to save your world, because when you compile it, you get everything back. So I've got my ant now eating the sugar cube when they collide. The E is an easy mark. It's playing the sound. Now, I just want to point this out. The sound has been in the same place for the last however many years we've been doing this exam. It's in the sounds folder, and it's always been called pop.wav. Do not rely on it being called pop.wav for you. If I was an examiner, that's the sort of thing I would change just to see if people have been copying exactly what they've seen in tutorials or whether they actually understand it. We need to add, once we've removed the sugar cube, we need to add greenfoot.playSound, which shockingly plays a sound. And in speech marks there, you give it the name of the sound file that we're dealing with, so pop.wav. That's not necessarily, remember, what you're going to have, but it has been pop.wav for the last 20,000 years that we've been doing this exam. That's me exaggerating. Compile it, should be okay. At this point, if you haven't got a computer with speakers in that hasn't got a sound card or a sound driver registered and working, when you run this, instead of hearing the lovely pop sound, there we go, that lovely pop sound that hopefully you heard, if you haven't got headphones plugged in to a computer with no speakers, sometimes that can cause a crash. That's worth remembering pre-exam. So now I've done that question, I've played the sound, add a counter. Now, adding a counter is reasonably straightforward. We're going to go new counter here and place it in the screen. Now I'll try and place it where they've placed it. So I've got it there. You want to save your world. So we're going to add a counter and we're going to edit the code so that the counter displays how many sugar cubes have been eaten. Now this is reasonably straightforward because we've already got the code in the ant. And so here, just into this bit, we're going to tell it to increase the counter. But we need, first of all, to make sure that the counter is understandable from the world. So we're going to go into our world. We're going to go to ground. And we'll see that there should be some code in there for where I've made the counter here. Okay, that is the code that was added automatically when I added the counter to the page. We're going to take this line and we're just going to move it out of this prepare method and we're going to stick it up here. Now you'll see that it's already done that for me. It's already they've already pre-prepared that, so I don't really need that in this case. We've already got a counter up there, so that should work exactly as it did before. That needs to be here because the counter needs to be accessible. It needs to be accessible from other methods. What it's doing is this is the bit that tells the counter to be returned. So check that works. As long as that's all there, you're good to go. We then need in our ant to tell it about the counter and to increase it. So we're going to say counter, and that's the name of this particular counter, equals ground.getCounter. Now that's the method that we wrote, the method that they had there already. Now from that point there, we are going to do counter.bumpCount. And in the brackets, we tell it how many to bump it by. Now we need to add 1 to it. Compile that. Now, if you're thinking, where's bump count come from? In counter, we should see a method here called bump counter. Bump counter, not bump count. That's why it's shouting at me. So it's already added by the WJEC. It's a very simple method. It's just adding 1 to the total count on the counter. So if you need to remind yourself where it is, just go into counter. It's the method with bump something on it. So bump counter by 1. That should be okay now. Now if I run the game, as I eat my sugar cubes, I should, hopefully, if I can manage to successfully get that sugar cube, increase my counter by 1, which I haven't done here. So let's see what's going on. I'm going to assume that this is the bit that doesn't work.
Remember that this was the part of the assessment that had to be recalled during the live exam.
The rest of the code, though, looks nice there. That should work fine. So once we've added the counter, we need to edit the code so the counter loses a point if the ant collides with the water drop. So again, remember what we do is we put the code on the bit that doesn't disappear. Since it's not asking us for anything to disappear, we're going to do that here. So I need to tell it about a water drop. I need to use this code here to tell it about water drops that are on top of me. I need to say if the water drop is not equal to null, again, if there isn't not something on top of me, so if the water drop is not empty, if there is a water drop there, then what I'm going to do is take my counter. I'm going to take both those lines of code there, take my counter, and I'm going to take away 10 points. So 1 point is deducted. So to take away a point, I'm just going to do -1 there. So there we go. That works fine. We're not going to see it work because, of course, this code was not working with WJEC. It was broken. So that was a particular concern there. Okay, finally, save our world as Final Ants 9. So it was called Final Ants 9 in the first place. So we just go scenario save, and we've got our finished game. So that was a 100% complete piece of work there. As you can see, those last counter problems were an issue because of the way they built the file. You won't see that problem quite so much in any other of the implementations.